We're going to be looking at examples 6 and 7 in your section 4.2 notes. So example 6, we would like to find the distance across a protected cove at a lake. So we have a surveyor that makes the measurements that are shown in the picture. We have an angle that's marked 180 degrees. We have from A to C is 65 yards and from B to C is 105 yards. So we can see that we have a side angle side triangle. So this is a situation where we want to use the law of cosines. Our job is to find the distance across the lake. So since it's across from angle C, I'm going to go ahead and call that distance side C. So my goal is to find side C for this problem. So the law of cosines version I want to use is the following. C squared is A squared plus B squared minus 2AB cosine of angle C. So plugging in what I know, A is across from angle A, so that's 105. We'll square that. B across from angle B is 65. Then we're going to take 2 times 105 times 65, and then we're going to have the cosine of 80 degrees. Okay. At this stage, you could go ahead and take the square root of both sides. Once you do that, you get an estimate for the distance across the lake, and it ends up being 113, and our label for this problem is yards. Okay, and that completes example 6. For example 7, we have given to us that an industrial piece of real estate is priced at $4.15 a square foot, and we want to find to the nearest 1,000 the cost of a triangular lot, and these are the measurements that were given. So we have a side situation. So since we're trying to find the cost, we need to actually look at the area of this triangle. This is going to be using Heron's formula for area. Okay, so the area for this, the formula we're going to use is S times S minus A times S minus B times S minus C, and take the square root of that. Okay, so before we get started, remember that S is the semi-perimeter. So we need to add the 3 sides and take half of that. So I'm going to go ahead and add 324 to 516 to 412. Okay, so I'm going to go over here and do that part. And when I add and take half, I get that the semi-perimeter is 626 feet. So plugging that in so I can find the area of this triangular lot. I'm going to go ahead and take the square root, 626. It really doesn't matter which one of these you call A, B, and C. I'm just going to go in numerical order, or the order that I see them here. So I'm going to subtract the 324. Then I'm going to go ahead and subtract the 626 minus the 516. Okay, and then finally, I'll subtract the 626 minus the 412. Okay, so you can take the square root of this entire expression as is. You can find the answers for these, whatever you feel most comfortable with. You'll end up getting an area that's approximately 66,710. Okay, and I'm going to keep quite a few decimal places at this point. You can double check me on this computation. So that's the area of this triangular lot. So at this point, it should be pretty easy to find the cost because we know that's $4.15 a square foot. So to find the cost, we're going to take the area that we found and multiply it by our cost per square foot. All right, so when you do this, you want to make sure that your answer is to the nearest 1,000. So you should get $277,000 if you round that appropriately. That completes example 7.